2. Hi again, and today is Wednesday, 4/8/20. It's not really, but that's for the class. And we have been covering 11.1, 11.2, and 11.3, and we're going to head into 11.5. But before that, a number of people have been asking me to solve some problems from the homework in these. They seem to have some difficulties. So I'm going to do some problems from the homework today. And we're going to do problems from 11.1 and 11.2 basically. And let's look at problems from 11.1 first. And 11.1, of course, is the natural logs. So it's natural log differentiation. Let's get the basic formula down here. You can put it in the corner. I'd rather put it up here. So since we already have that down, I'd rather put it up here, gets it out of the way. But if y equals a the log of x, then dy dx is going to be, well, let's say a the log of u could be any function of x. This is going to be a over u times du dx. That's the basic rule which we'll be using for logs. So let's take some examples. Some of these are from your homework. We have here y equals the natural log of x minus the natural log of x minus 1. Well, if we look at our formula, dy dx equals the derivative of the natural log of x minus the derivative of the log of x minus 1. That's a x minus 1 close parentheses. Okay, this pen seems to be a little bit light, so let me change another one here. This could be better. So here we're going to have the derivative of log x. Here x, u is x. So if you look at over there, if you look at this term, you're going to see u equals x, a equals 1, du dx equals 1. If you look at this one over here, u equals x minus 1, du dx is 1, and a is 1. So let's substitute both of these in our log rule right up there at the corner of the board. And what we get here is 1 over u du dx, which is 1, plus 1 over u du dx, which is 1. Okay, so, but in this case, the u's are different. So we can call this u2 and u1. And this is going to be 1 over x plus 1 over x minus 1. And this is our solution. Very simple one. Doesn't need any lot of machinations. Okay. So now what we're going to do is we're going to do another one, which trying to step up here in degree of difficulty. We're still on 11.1. As long as we're in natural logs, we're in 11.1. So let's do another problem. This example, we'll call it example 2. And what we get is y equals the log of 2x squared minus x. Well, using the log rule up there, we let u equals 2x squared minus x. Taking the derivative with respect to x is 4x minus 1. And of course here a is still 1. There's a 1 outside here. So simply the derivative with respect to x is going to be 1 over u, 1 over 2x squared minus x times du dx, 4x minus 1, 4x minus 1 over 2x squared minus x. You cannot factor that. You can factor out an x, and you're not going to get what you get there. So that's your answer. Very simple. Now let's go to something a little bit more complicated. Some of you have asked me to do this, so I always lose this because I don't put it back where I should. Notice these were direct usage of that log rule. Now let's take another one. Example 3. And here we have y equals the natural log of t squared plus 3 over the square root of 1 minus t. Of course, we can't deal with square roots very easily, so we simply change the problem to t squared plus 3 and 1 minus t, as you know, to the 1/2. So now we have it in a form that we can do this. Now we have a problem, though. You say the quotient rule, but you can't do the quotient rule because this is inside the argument of log. So I would say when you get something like this, this looks a lot like the natural log over y over x. Or we can call this u over v if you want. We can call this u, and we can call this v. We can call that u, and we can call that v. Now, there's a log rule, very simple log rule, which we've done before. This is going to be the natural log of u minus the natural log of v. So let's do that to this problem. Let's take y equals the natural log of the numerator, 2 squared plus 3, minus the natural log of the denominator, 1 minus t to the 1/2. Notice we've simplified this problem. We don't have to worry about quotient rules or anything like that. And what we can do here is we can make u equal t third plus 3. du dx is 3t squared. So we're going to take the derivative of this with respect to x is going to be, look over there, a over u, a is 1 here. So it's going to be 1 over u, which is 1 over t squared. Okay, I'm sorry, that's my fault then. I wrote that as a 3. T squared is going to be 2t.
You have a few u's running around too. Using a subscript might be clearer, like you did in the last one, u sub 1, u sub 2.
Yeah, we're going to do u1 here and u1 because you're going to have another u.
There's also u up here.
Yeah, I probably should have called it something else, but...
the subscript makes it clear.
Yeah, so I could call this u0.
There you go.
Okay. And that would be this and this.
Correct.
Okay, so here we have dy is going to be 1 over t squared plus 3 multiplied times 2t. Now what about this one here? Well, this is the log of 1 minus t to the 1/2. Now this looks like a chain rule, but let me use another log rule. We call this log rule 3. When I have the natural log of something raised to the a, I can write that as a natural log of x. So how can I write this? Before I did this, before I took I'm going to take this is going to be the derivative with respect to t in this case, because we have a t, of what? I'll take the 1/2 the log of 1 minus t. Well, let's erase the top of the board here and continue on with this problem. Notice as I use the log rules, the problem got easier and easier. So let's write that back up here. Equals 2t over t squared plus 3 minus the derivative of here. Now notice, what do we have here? If we have here, we can set a u, let's call it u2, equals 1 minus t, and du2 over dt is going to be minus 1. And of course now a is 1/2. This goes with this.
Also, you have du dx over there. So du dt.
I'm sorry?
Du dt.
Oh, this is du dt, right. Okay. So that was 1. So now we just substitute for here. Substitute u2, dut, and we get, in substituting it in here, we get minus 1/2 1 over 1 minus t times the derivative with respect to t, which is minus 1. So the answer is going to become 2t over t squared plus 3. Minus times a minus is a plus. 1, well, we put the 1 over here, 2, 1 minus t. That's our derivative. Notice it's a very, very complicated function, and I use 2 log rules. We call this log rule 2, which is the log of 2 variables divided by each other, and we call this log rule 3, which is the log of a variable raised to a power. So you might want to simplify things using log rules, and we'll be back for our next 15-minute section.